2 plus 2 equals 5. Here is the proof. We start with 0 equals 0. From there, we can rewrite those zeros as 20 minus 20 on one side and 25 minus 25 on the other. It looks different, but the balance remains the same. Next, we break these numbers down into their factors. On the left, we have 4 times 5. On the right, 5 times 5. By factoring out the 4 and the 5, we reach a crossroads. 4 times 5 minus 5 equals 5 times 5 minus 5. Now here's the trick. If we simply cancel out the common terms on both sides, we are left with a shocking result. Suddenly, 4 equals 5. And since 4 is just 2 plus 2, we've just proven that 2 plus 2 equals 5. So can you find the mistake? If you can, write it down in the comments. Now let's prove that 2 equals to 1. We start with a simple assumption. A equals B. If we multiply both sides by a and then subtract b squared from the result, we create an equation ready for factoring. On the left, we have a difference of squares. On the right, a common factor. This reveals a minus b on both sides. It looks like a simple cancellation, leaving us with a plus b equals b. But remember our first step. If a and b are equal, then a plus b is just 2b. Dividing by b leads us to the impossible. 2 equals 1. So can you spot the error this time? If you can, write it down in the comments. And again, if we add 3 to both sides, and suddenly 5 equals 4, which gives us 2 plus 2 equals 5 again. But where is the mistake? Now, let's prove again that 1 plus 1 equals to 3. We start with 1 equals 1. By substituting those 1s for 41 minus 40 and 61 minus 60, we set the stage for a perfect square. We break those numbers down further into 16, 25, and their products. We rewrite both sides as squared binomials, 4 minus 5 squared and 6 minus 5 squared. Now, if we take the square root of both sides, the exponents vanish. We're left with 4 minus 5 equals 6 minus 5. Add 5 to both sides, and the math says 4 equals 6. Divide by 2, and we get 2 equals 3. Therefore, 1 plus 1 equals 3. Again, if you can spot the errors, leave a comment. Let's move to the next one. 2 is equal to 1 plus 1. 1 is, of course, equal to the square root of 1, and 1 is equal to the product of minus 1 and minus 1. Apply the square root to each of the terms. The square root of minus 1 is equal to the imaginary constant I. I times I is equal to I squared, and I squared is equal to minus 1. So 2 is equal to 1 plus minus 1. But 1 plus minus 1 is equal to 0. Therefore, 2 is equal to 0. We have an absurd conclusion that 2 is equal to 0, but we started out that 2 is equal to 1 plus 1, and every step was seemingly true. Can you find the mistake? For those who can't find the errors, tell me if you want a video debunking those proofs.